All right, all right, all right. Here we are again, back with a little bit of algebra. Go ahead and title your notes. Algebra 5.1, solving systems of linear equations by graphing. All right. First off, let's talk about what systems of equations are. So, a system of a linear equation, or a system of a linear equation is a set of two or more linear equations in the same variables. All right, so you have to have the same variables. If one's x and y, the other one can't be a and b. All right, here's an example. We have an x and a y. And then here we have an x and a y. So we have two linear equations. Both of them are using the variables x and y. So this is a system of linear equations. All right. A solution of a system of linear equations in two variables is an ordered pair. That is a solution to each equation in the system. And this is important. It has to be to each equation. So you can underline that or highlight that in your notes. All right. Let's look at an example. What about 2, 5? The point 2, 5 is 2, 5 a solution to the system of equations in the example? All right, well, let's check it. In order to check that, we can plug it in. The 2 is the x, the 5 is the y. So if we have x plus y equals 7, and then 2x minus 3y equals negative 11. We can go ahead and check this point by plugging it in. All right, so let's plug in 2, 5. 2 is x, and 5 is y. All right, we're going to carry everything else down. 2 plus 5. We want to know, does this equal 7? Well, let's do a little bit of addition. 2 plus 5, that's 7. All right, so 7 does equal 7. So therefore, that point works with the first linear equation. Next, let's plug it into the second one. We've got 2 for x and 5 for y. Carry everything else down, so 2 times 2 minus 3 times 5 is equal to negative 11. We want to know, does that equal negative 11? All right, well, 2 times 2 is 4. 3 times 5 is 15. Does that equal negative 11? Let's do a little bit of calculating, subtracting 4 minus 15, and that is negative 11. And that is indeed equal to negative 11. So that works there also. That means we can now answer yes. The point 2, 5 is a solution to the system of equations. All right. When you want to find a solution, so if you're given two equations and you want to find it, there are several ways that you can do that, several ways to solve a system of linear equations. One of those ways is by graphing. Okay, one way to solve a system of equations is by graphing. When you graph those two lines, the point where they intersect, that's a point they both have in common. So that's the solution. All right, the solution is the point where the lines intersect. Okay, let's look at an example of this. All right. The solution is the point where the lines intersect. So if we graph these lines, here we have an example. We're going to graph both of these lines. Let's start with the first one. I'm going to make that one, use green for that one. We're going to start at the y-intercept. The y-intercept is negative 4. So we're going to go down to negative 4 on our graph. Now you should use graph paper for this. All right. Don't use a hand-drawn graph unless you're being very precise using a ruler. Otherwise, use graph paper. If you want to solve using graphing, your graphing has to be precise. Okay, start at -4, and now we're going to follow the slope. The slope is 2, so we're going to go up 2 over 1, up 2 over 1, and just keep going that slope. There we go, beautiful. And now get out your straight edge. All right, we want to use a straight edge to make a line. There we go, beautiful. All right, let's look at that next point. That next point, the next line, we're going to start at +3. That's the y-intercept. So we'll go up 3, start right here at 3. And then the slope on this one is -1/3. That means we go down 1 over 3. And over is always to the right. Okay, so down 1 over 3. Looks like we've already found our point of intersection there. Now we can follow this same slope, back 3, up 1, back 3, up 1. All right, if we go in the other direction, and then get out your straight edge and connect these points. All right, there is our beautiful line. Now we can see the point of intersection. Where these two lines cross, that point is on both lines. Right? So if we take that point, it should work for each one of these equations. So this point right here, the point of intersection, that is at 1, 2, 3 on the x-axis, and at 1, 2 on the y-axis. So that point is 3 and 2. That is the solution. 3, 2 is the solution to this system of linear equations. You can always check that by plugging it in. So let's plug it in here. 2, y should be 2. Does that equal 2 times 3 minus 4? Well, that's 6 minus 4. Does that equal 2? Well, 6 minus 4 is 2, and 2 does equal 2. Therefore, that's correct. Works for the first equation. Let's see whether we graphed right using the second one. Plug in 2 here is equal to -1/3 times 3 plus 3. 1/3 of 3 is 1, or you can cancel out these 3's, and then we get -1 plus 3. Does that equal 2? -1 plus 3 is 2. And 2 does equal 2. It is true for the first one, and it is true for the second one. All right, so therefore, this is our solution to the system of equations. All right, one more example here. Let's graph both of these. Start with -1. Right there, -1. We go down 2 over 1. Down 2 over 1. We can continue that same slope and then go in the other direction also. Make a couple of points there. And a line through those. Go. Beautiful. All right, now we're going to start for the second line at +2. And then the slope, remember when the x doesn't have a coefficient, a 1 is implied. And the slope is not 1x, it's just the 1, just the coefficient. And that 1 can be written as 1 over 1. So from this point 2, we go up 1 over 1, up 1 over 1. All right, and we can go the same in the opposite direction and then connect those, and we can see where that intersects. Now again, it's important that you're graphing with a straight edge. All right, right here is our point of intersection. That's at -1 and 1, -1 and 1. We can check this again to see whether we got it right. Now checking isn't always necessary, depends on what the question asks, but it can show you whether you got it right or not. Okay, because we could have graphed anything here, and if our graph is wrong, then our solution is wrong. So we can check to see, did we graph it correctly? Maybe I got the slope wrong. Maybe I got the y-intercept wrong. So always good to check your answer. Plug in 1 there. -2 times -1 minus 1. -2 times -1 is +2 minus 1 is 1. And that equals 1. All right, that works there. And then check the other one. Does 1 equal -1 plus 2? Well, -1 plus 2 is 1. And that equals 1. All right, so we did a good job. Okay, there you go. On today's assignment, you're either going to have problems where you have to determine is the solution, is the ordered pair a solution? Then you will do what we just did for checking here. You will plug it in and see, is it true for both? If it is true for both, it is a solution. If one of them says something like 3 equals 5 or 10 equals 2, that's not true, right? And if one of them is not true, then it is not a solution to the system. Okay? If both of them are not true, it's definitely not a solution to the system. All right? And the other thing is solving by graphing. So you create a graph and see where they intersect. All right. That's all the fun we're going to have with this today. Check in again next time for another fun lesson in algebra.